So if we switch back a slide for a second, we can see that this 11.1, the equilibrium constant, is given to us right there. So that's where this came from. Now, this is a complete setup that we have now. We've used our equilibrium expression to then fill in numbers to actually solve the problem. And if you recall, once again, I'm asking for how many moles of Br2 and BrCl are also present in the reaction mixture. So we've actually already solved for Br2, because if you recall earlier, I said, hey, Cl2 is 4 moles per liter, because that was given to us, but that 1-to-1 ratio means there's also 4 moles of Br2 as well, and if you write that as a molarity concentration, 4 moles per liter. But our BrCl2, since it's our unknown, we have to solve for it, and that's our only unknown that we have at this point. And so it actually becomes fairly easy to solve. You just have to use your math rules to do it. So we have our unknown down at the bottom right here, and so if we wanted to isolate this and get it by itself, all we have to do is multiply both sides by BrCl squared. So if we multiply our right side by BrCl squared, well, that's going to cancel this out. And then we multiply our left side by BrCl squared, we would get 11.1 times BrCl squared equaling this. And so once we've done that, that's cool. We now have to continue to isolate our BrCl squared by dividing both sides by our 11.1, which after we do that down here, that's how we end up with this expression right here. Because we have our BrCl squared isolated on this side, we have our 11.1 on the bottom, and our 4 times 4, 4 squared right there. Then you simplify that expression even more. You have your 16 divided by 11.1, giving you a number which then you have to simplify further by square rooting both sides, because this squared means that we have to get rid of that. So if we square root the left side, we have our square root of BrCl squared equaling just BrCl, and we have our right side reducing all the way down to 1.20 moles per liter. Now, I'd like you to pay attention to the fact that we are still in a concentration here. That's what these brackets mean, that the concentration of BrCl is 1.2 moles per liter. But since we're in a 1 liter container, once again, that I told you in the problem up there, in a 1 liter container, see that? That means that you have 1.2 moles because you're in a 1 liter container. So that information in the problem that I gave you allows you to say, well, now there's just 1.2 moles of BrCl, and that would be your answer to that problem. Because if you recall, I wanted to know how many moles of Br2 and BrCl are present, and I did not want to know their concentrations. You solve for their concentrations and then use that to actually answer the question that I am asking. So basically what I'm telling you is you need to be aware of what the problem is asking for, because if you put the concentrations like this on a test and didn't actually answer the question, I'd be like, well, you did your math right, but you didn't answer my question, so you would still lose points for that. So always, always, always pay attention. I'm sorry this video got cut up into 2 videos, but again, with my software and not having access to the same software I have access to at school, it makes it a little bit harder, but I'm sure that you guys can figure it out. If you have any questions, again, email me. My office hours are going to be weekdays from 8 to 10 in the morning. I hope this was helpful for you, and I will do another video about how to solve iceboxes and all that for the work that you are going to be doing after spring break, assuming that we are not going back to school, which at this point, it's highly doubtful that we will be going back to school after spring break. Have a good rest of your day. Stay safe, you guys.